These are the real stars of the show, though.
Ah.
Elsa May. Yeah. You want to say hi? Say hi, Elsa.
There's a demand up there, but how you get...
Well, let's see how do we get the consistency from our producers. I'm looking for the guys
You've had it kind of up and down summer.
sometimes it's hot and dry, and sometimes it's pouring rain.
Yeah, I think. Welcome. We also want to welcome Women Grow Ohio over there have joined us. An amazing group of female women farmers and growers celebrating what women have always done. Rural Action is here, a good partner of ours, a nonprofit that helps us. This is Tom, the Sustainable Agriculture Coordinator. So this is Mike Stroh, our Farm Service Agency
There you go.
representative. Green Edge people, just raise your hands. Because some of you have shirts on and some of you don't. These are all your crew. This is the crew that grows the vegetables that people eat. Mary Nally is the director of Community Food Initiatives. The first farm tour starts as soon as Dan and Kip divide the group up. So welcome, there's food there. Welcome, enjoy the afternoon.
He is a fun guy.
I guess he's kind of sick of that joke.
It's not funny anymore to you, huh?
He's extremely knowledgeable about growing mushrooms. So half of y'all come with me and half you go with Shaquille. And how long do you think you'll be? 10 minutes?
I don't know. I mean, I can talk about mushrooms for a long time.
Everything is packed, and we have maybe 5 or 6 people working in here at once. And so you can move a lot of produce through here. We can service several hundred people at a time in here, just moving stuff through. And it's all FDA approved, and it's pretty simple. So if you wanted to build one, it wouldn't be that hard. Just roofing and a little bit of caulk and boom. And about most of these tables that I use restaurant place in Columbus. I'm a half mechanic. We got those to work. And this is a, if anybody can tell me what this is, I'll give it to them. This is a machine that Ohio University's Mechanical Engineering Department designed. It cleans the sunflower microgreens. So when the microgreens have the hulls on them, and that's it's real labor intensive to pick all those hulls off. We brush them in there and get a lot of the hulls, the majority of the hulls off, but this machine will, as you can see, it's just it's a washing machine motor, and this is an agitator that fits on top of the thing, and it just goes, and so the sunflowers just come right out. The hulls are lighter than the sunflowers, so they'll float up to the top, and they'll float through the holes in the screen. And so we can just skim all the hulls off, and we don't have to pick them off anymore.
Oh, that's great.
Yeah, it's one of those. It's one of the kind of work like, my gosh, a machine should do this. This is the meaning. Human beings have to do that, take that stuff off. So
Ohio University of Mechanical Engineering.
yeah, they have projects. The senior class has a project. Greg Kramer, Professor Kramer, is the head of that department. They solicit the community all the time for different projects. Greg is a super nice guy. I mean, he's very, very approachable. really easy to talk to. So if you had a project, you could talk to them about it and say, well, yeah, come and see me when the next class is trying to get some projects together. We'll do something.
That is so cool.
Everybody's very glad about it.
Sunflowers.
Yeah. This is sunflower. The first thing that's really important is what we're growing them in. So this is the soil that we're growing them in, and you can see there's quite a few earthworms right there already. I know that one. I don't know this guy. But they're here. They're in the trays with the plants growing. They're everywhere. When we cut the sunflowers, the whole bunch goes right into in here, and then it breaks down over a period of time, and all this is eaten up by the worms, and then it's used again. So it's pretty much a closed system. The only thing that comes in here is seed and water. And we do amend. We do add some micronutrients to this now and then. I remember that one.
What kind of micronutrients?
Anything from selenium, just whatever. Dan would be the person to ask about all that because he handles all the
soil.
nutrients. We did notice that, and you're welcome to pick one off. But if you pick one off of the sunflowers here, there is a sweetness. We did notice a change in their taste.
Ah, because of what you had.
Keeping it.
Do you do biochar?
Yeah, we do biochar. They'll be in Columbus on Wednesday. The next crop they planted yesterday. This was planted yesterday,
Oh my
and
gosh.
it'll be ready to go. It'll go on the shelf either tomorrow or Tuesday. Really an excellent use of space.
2 crops a week.
So, and that's how all this stuff is. It's all planted and spaced it out. So,
So are these different type of sunflowers?
This is buckwheat. This is going to be harvested again on Tuesday.
How do they harvest it?
We just cut it with scissors.
Oh.
You have to pick out there's little buckwheat growth hulls. And so you have to pick those out, but there's nothing like picking out sunflower hulls. It probably takes longer than anybody else in here to grow, so it's probably 10 days old when it's harvested. And again, all these crops are in various stages incubating and ready to plant for Friday. So there's this whole system that's just constantly going through. And actually Friday's kohlrabi.
What's your humidity kept at in here?
We try to keep the humidity low. That's why I had that big fan going. So this is kohlrabi. So it'll look like that stuff that we just looked at. This will look like that on Friday. These are radishes, and it's a daikon radish. Pinch one off and taste it if you like it.
Bite to it.
Yeah, sprouting seed has to be tested for E. coli salmonella, and sprouters have to send each batch off and have it tested if you're running a commercial sprout.
So your water has to be controlled.
All of our water here is municipal water in this room. Now down below we're irrigating out of ponds on the property, but in here and in the mushroom house and in the packing room, all of it's municipal water. We were fortunate that municipal water came down the road, and the health department's like, oh, you gotta get that city water. Even if I buy, and I have in the past bought seed off of some farm, I just send it off and have it tested. And that way I'm covered. It's not a big deal. It costs you $15, $20 to get it tested, but that's how we do it. So you're not in here very long, a few hours. Twice a day, 7 days a week. That's all.
They stopped growing, huh?
Yeah. They have special bulbs. You don't have to have full spectrum lighting in here because these plants aren't growing that long.
16 hours a day.
yeah, the things that I want to do in here is I'm looking for different tray material. The tray material's gotten really flimsy. I talked to the manufacturer, and they said, yeah, we make other trays. My distributor doesn't carry them. But they were forced to keep making trays flimsier and flimsier because the price, they had to keep getting their prices. They were putting pressure to get the prices down. So it's kind of an interesting little scenario where everybody's pushing everybody to get the lowest common denominator. And you know, before trays used to last us for months, and these last weeks now instead of months. You can see there's the worms in there, and probably 3 weeks it'll look like, you know, like that one I grabbed out of. The vast majority of this will be gone, and you know, and it'll be all this and a bunch of worms. Yeah, so they just keep going and going and going. So you're saving, you know, a couple grand on doing a system like that. So that's how we do this. And so yeah, I love it. So you can buy Penny, the one woman that was with me down there, I was talking to, they had this sitting at their place. They gave me this. You know, I mean, you can buy these old things for nothing. Nobody wants these old boxes. You know, and so yeah, it's just like, yeah. So we have more money into the roof and to the cool bot than we have into the whole thing. So it's really good, and you know, you can buy the extended warranty on the air conditioner. But and then and this one I have another thermostat, just a regular house thermostat in there. So in the winter, I have a radio, you know, just like those heaters, the plug-in radiant heaters, like the old hot water heaters. It's sitting on the ground underneath back there. If you just see what I'm looking at. And I just have a thermostat in there, so when it gets down below 37, it kicks on, and the heater comes on. So, you know, I don't do anything. It just runs, it just heats and cools itself. And yeah, it's pretty easy to do. You know, that's all they do now. They developed a little gizmo. So all they do now is test brands of air conditioners and see which ones are functioning the best with their system. And so yeah, that's really nice. It's a really nice system. I'd say it's pretty cool, but that would be redundant.
Cool.
So yeah.
How do you spell cool?
Koolbot. And if you Google it, it's right on. It'll come right up. And once or twice I've had to call them, and they have really good tech support. So it was really nice. But yeah, I mean, I think that silver air conditioner over there where the crates are standing, we've got, you know, probably $4 grand, $5 grand into that thing. And we've got probably, you know, $1 grand, $2 grand into this. You know, but then we built a fancy roof.
Atmosphere?
Yes.
Humid?
Testing treatment.
It smells better.
We grow mushrooms in here,
Yeah.
as you can see. So we grow shiitake and 3 varieties of oyster. Most of what we grow is shiitake. It's what we're standing in right now. They're grown on hardwood sawdust with a grain supplement. So this is the inside of these blocks. This is a spent block. We do not make the blocks. They're produced by a company in Pennsylvania who produces millions of these blocks a year and does not produce any mushrooms. So that's pretty much the standard through the industry is you buy blocks from somebody. They're actually a wood products company, so they have the ability to access all of this material and handle it in an efficient manner. But the basic process goes, hardwood sawdust is sterilized in a giant steam pressure vessel. And once it's thoroughly sterilized, it comes out, it's cooled to the point where the temperature won't kill the mycelium, and then the containers with the sawdust in them are inoculated using rye grain that's had the shiitake mycelium grown, sterilized rye, and then shiitake mycelium grown throughout. It's about 3 weeks, I think, is the culmination time for this strain. and then they come to us. We get new blocks every 2 weeks. We get about 150 blocks right now.
Well, they're already inoculated.
They're already inoculated when we get them. Yeah. And then we soak them. That stock tank that we walked past on the way in here in the other room, it's got blocks in it right now soaking. That gets the substrate up to the desired moisture level, so it'll start to produce mushrooms. Like if you think about mushrooms from a plant standpoint, it's easy to understand, I guess, that the mycelium would be like the plant that you're growing, and the mushrooms would be the fruit, and then the spores that come out of those mushrooms would be the seed, essentially. But unlike plants, mushrooms are more like an animal in the sense that they don't make their own food. They need a food source, and instead of producing oxygen and using carbon dioxide, they do the reverse. They are actually generating carbon dioxide in their growth process. So, that being said, the air exchange in here is crucial. If we get excess carbon dioxide levels, that really throws things off in production. So, you hear this thing humming behind me, that's our air exchange. And that there's a pipe there with a filter in it. That's the stale air from the grow room right above where you guys are standing. The air from the grow room goes out through that, it's dumped outside, and then fresh air comes in. From outside. So I'm not sure exactly what the total numbers are at this point. The last year that I did the math on, we produced 9,000 pounds of mushrooms in this room right here. About 7,500 pounds of shiitake and 1,500 pounds of oyster. So it's not totally full right now, as you can see, but the blocks, we get new blocks every 2 weeks, like I said, and each round of blocks is split into 3 groups. We soak blocks 3 times a week, and so that we can spread the harvest out. You know, we put all 150 of those blocks in here. We're going to be picking 250 pounds of mushrooms over the course of 4 days, which is not what you want to be doing in here. So this is the first crop here. We just started picking these blocks today. This side of this rack and that full rack over there, we picked about a pound today. The other side of this and that next rack over, I think I picked 16 pounds off of that today. So we pick mushrooms 365 days a year, barring any unforeseen catastrophes.
Do you pick the largest and then come back?
It's actually based more on maturity than it is on size. Ideally they would get large, but sometimes you get a block that produces, you know, a whole bunch of tiny mushrooms, or a block that produces, you know, very few larger mushrooms. This is pretty consistent, but basically we're looking for something like slightly more mature than this. Once this veil is broken and the cap starts to enlarge, but before it flattens out. We want to try to get to it before it starts to release spores. That once it starts to release its spores, the shelf life decreases dramatically, and the air quality in the grow room decreases dramatically as the air is filled with spores. So we try to get, you know, some sort of balance between a good shelf life and a high yield. You know, not to say that something like this isn't edible, it is, but if you wait another day, I mean, this will probably be picked tomorrow, possibly Tuesday, but most likely tomorrow. So these blocks will be finished. These blocks came in here last Tuesday. Yeah, last Tuesday. And they will be done producing their first crop by probably this Thursday. So this time of year it's about 10 days, 10 to 14 days. We usually start picking in 7 to 10 days, and we pick for 4 or 5 days, and then the first crop is done. And the blocks go back, they go out into that room there. There's a rack full of blocks. They spend a week in there where they dry out, and mycelium kind of has a little rest period. And they get re-soaked and come back in, which is these blocks here. They've already produced 1 crop, and they're working on their 2nd crop. It's already in there, right? So the mushroom is just, the mushroom is the mycelium's effort to reproduce itself. But the mycelium can only grow to a certain extent because it's consuming whatever it's growing on while it's, it's producing enzymes that decompose that material, whatever the material may be, in this case sawdust. And so it can only do that for so long before it exhausts its food source. So this is its response. We get 2 crops. Some growers get more. Conventional growers usually get something more along the lines of 4 crops, but generally there's some sort of product used in the soak tank water to control surface mold. Usually it's like pool chlorine, and then sometimes fungicides are used in the grow room. But since we're not using any of that, we used to do 3 crops, and the trade-off for the amount of mushrooms produced on the 3rd crop for the labor that it takes really just wasn't worth it anyway for us. We're better off to just put out the money, get new blocks in here, and get a better crop, and send these blocks down to the compost pile. They make a really nice compost.
What would you suggest for someone who just wants to do mushrooms for themselves to eat?
Logs.
Can you
hardwood? I would do hardwood logs. Yeah, it's a longer wait, and the crops are less consistent in terms of when you get them and what you might get. But a white oak log with a good shiitake strain might produce for 7 or 8 years.
Oh, really?
You might only get 2 or 3 flushes a year, but there's been a lot of work done too over the last 10 years or so with different strains that are adapted to different seasons. So you can, if you just have a few logs of several different strains, you might be able to have mushrooms close to year round by using different strains. And then there's a lot of strains that are adapted to different wood types, where it used to be kind of, if you didn't have white oak, you might be able to use red oak. If you didn't have red oak, you were pretty much out of luck. But now there's some other strains that are well adapted to, like sugar maple or even some of the softer hardwoods. But oyster is a good one to start with. Really forgiving in terms of substrates, what it'll grow on, and competing with other mushrooms. Like, you almost never see a hardwood shiitake log with shiitake and another mushroom fruiting out of it. Shiitake's not as vigorous and it won't compete well with other mushrooms, but you might see an oyster log with 2 or 3 mushrooms fruiting out of it, and it will compete well with other things, with other mushrooms or other fungi. And it'll grow on a wide variety of woods and different wide variety of substrates. Our oysters actually are grown on straw, on wheat straw, as opposed to sawdust. Not all mushrooms will produce well on straw, but oysters are one of them that will. To get a good yield, they need a grain supplement. Some growers use cottonseed meal, some use wheat bran or oat bran. But yeah, the straw can be pasteurized as opposed to being sterilized, so it's a little bit easier to work with on a bulk level. You can just essentially boil that straw. If you have access to oyster spawn, you can soak the straw for a period of like 4 or 5 days. It usually needs to be chopped, so it's a little finer. Soaked for several days, and then inoculated. But there's a lot of good resources. There's a lot of information, I'm told, on the internet.
Like your thing.
But I don't really know about the internet. There are several really good books. There's one that recently came out with the guy who wrote it. His name is Trad Cotter. He has a company called Mushroom Mountain in South Carolina. And I believe it's called the Organic Mushroom Farm, Organic Mushroom Grower, I forget. They're all titled something very similar, but there's another one by Paul Stamets that's called Mycelium Running, or How Mushrooms Can Help Save the World, that covers a variety of topics, how to use mushrooms for different things within forestry and for rehabilitating, chemically contaminated. His argument essentially is there's a mushroom strain adapted to breaking down everything. Anything reasonably natural, like obviously you're not going to get a mushroom that's going to colonize this metal, but there are mushrooms that you can colonize a substrate with that might say reduce substantially the level of hydrocarbons in a soil. Or, you know, oysters, the big example that people cite with breaking down petrochemicals. They've been using them in oil spills, contaminated lands. One of the big studies was, I believe, in Washington. It was like a state transportation garage facility where the soil was so contaminated with years of oil and diesel and various other things, where they inoculated separate soil piles, and the mushrooms and the oyster mycelium produced out of the contaminated pile were giant, ridiculous. And when they tested them, there was no evidence of petrochemicals in the fruit bodies. I mean, they didn't eat them, but there was no evidence when they tested them. And then after the mushrooms were done producing, there was no evidence, or significantly reduced evidence, of the petrochemicals in the soil as well. So this big thing is like just finding the strains. To, you know, he's found mushrooms that will break down all sorts of things, from nerve gases to, you know, oil. And then, yeah, forestry applications, or, you know, utilizing the slash from logging operations instead of just burning it, to, you know, chipping it and inoculating it, and that helps to build the soil for future crops of trees. Significant reduction in carbon into the atmosphere. I mean, there's always arguable points where, yeah, you're running the chipper, which burns petroleum fuel, and then it's, you know, you can nitpick it to death either direction, but the point is somebody's trying to do something to help. Yeah. Anyway, back to what we actually do in here. Yeah, there's a lot of interesting things happening in the mushroom world at the moment. Mushroom, so we keep it back here. This part of the room stays wetter, and our mister is that fan contraption hanging from the wall over there. So it's got a humidistat. If it's, you know, if the humidity in here drops below a certain point, then that mister will come on. We keep the oyster back here, so it needs that higher humidity.
So they just poke out?
They just poke out. Yeah, and we do a yellow, a brown, and like a gray, blue. So this stuff will be picked tomorrow. This is the brown here.
And they just break them off.
Yeah, it depends on the yellow. We usually cut off because it usually wants to come with a big chunk of the medium that won't fit out that hole, so it creates problems. But with the oyster, one of the difficulties is if you cut them, you're left with this stem butt here that, as it decomposes, really can become a site for like gnat infestations, which we don't want, because they want to, I mean, they're doing their job in a natural system outside. That's what they would be supposed to do. The gnats get in there and they lay their eggs, and the maggots eat it, and then it's gone. You know, but in here we don't want that, because they'll get into these bags and reproduce in here, and that's a real problem for us.
So you need to pick mushrooms in like enclosed space, or?
I mean, not necessarily. They need to be in the shade for sure, but we do this way because it's very consistent, and we can, to some degree, control the environment in here and get consistent crops that way. They can easily be grown in the forest, you know, if you don't have enough shade, even under a shade cloth, depending on the mushroom and how it's grown.
What would be the humidity limit?
We try to fluctuate it with the shiitake cropping cycle. Ideally, we would lower it close to harvest time, and you get a better shelf life out of the mushroom if they're not wet when they're harvested. And it should be raised when the blocks first come in. They want a really high humidity. However, since we have up to 6 different groups of blocks in here at a time, we're not able to fluctuate it as much as we probably should. But we run anywhere from 80 to 95% right now. Right now we're at 91%. We try to run close to 60 degrees in here, but in the summer we're higher than that, and in the winter we're usually lower than that. If it gets much above 70, we start to have problems with mushrooms growing too fast and mold levels. And if it drops much below 55, it really slows the production cycle down a lot.
So if you see you have mold,
It doesn't go away, but it stops growing or slows growing when they're dry out there. And if it's really bad, yeah, we would toss the block, but
Mold.
it usually gets worse at the end of second flush when the blocks are getting ready to go in the compost anyway. So we just put up with it. It's not, not ideal, but that's the situation we've got.
Oh, give me a straw. Oh, she needs a bottle of water.
There we go. How are you? I'm so glad to see you.
Okay, wait a minute. We gotta have the I am the farmer. We can move the sign. Here we go. Let's move it. All right, that's good. Can she be in the picture too? If you do that?
Anybody can be in the picture.
Here we go. Funny one. Okay. This is funny. Yes, I did. Okay. Thank you, Trevor. Thank you. The rest of the day. Oh, we still have to. Would they clean them in there?
Well, yeah, let's walk this way. We'll begin. As you can see, a lot of the high tunnels have soil that's not getting rained on. Anytime you tweak a little bit what natural processes are happening, you're going to have effects with whatever happens underneath that. So what tends to happen on soil that's not rained on is minerals begin to stratify, and you'll start to get like a white crusting on the top. Sometimes it's called salinization. Different minerals are being condensed at the top, and even below that, the soil starts to stratify, and different layers will have significant imbalances of one nutrient or another, whether that's calcium or phosphorus or whatever. These plants do not like that. They're not happy with imbalances. The closer you get to the surface, the more intense that layering is going to be. You need to do something to mitigate that. What we found, at least for us, is if we take the top off and for a summer season allow the rain, so from May through September, whatever rains come during those times, to do its normal thing, then it leaches those minerals down and kind of puts them in a more even place. The cover crops are an important piece because the vast majority of microbe life that's in soil are in relationship to root zones. So the space right around the root zone, called the rhizosphere, is filled with way more microbe life than other areas. Mostly because they want what the plant provides. They've formed beneficial relationships because the sunlight that the plants are capturing is being funneled down in, and they're getting that sugar and everything else through photosynthesis and whatever. You want growing spaces to become more fertile, more productive, and you want to learn as a grower, a gardener, a farmer, how to replace what you take. Cover crops are such a key part of that. If you don't do those well, it's going to be really hard not to see your soil getting more and more depleted. You need to add more and more and more. So whether that's fertilizer, whatever you're adding to keep that ground growing, you're going to have to add more and more and more, unless you do practices like cover cropping. And it's even been estimated by some researchers that plants are so good at, one of the main things they do is feed off CO2, right? They're carbon dioxide eaters, and then they give off oxygen. And we're obviously the opposite of that. But it's been estimated that so much of our agricultural land worldwide is bare for a significant portion of the year. And you'll see this when you drive around the country, and it's even worse in different areas of the world, other countries. But as soon as a crop is done, then they'll burn it, disc it, do whatever, but keep it bare until they're ready for the next crop the next year. And it's been estimated that if all the farmable land was put in cover crops, that in less than 3 years, our excess CO2 in the atmosphere would be effectively gone. The only reason is that you're creating so much plant cover that wasn't there before. It's sucking all that in, and it's banking it into the soil. And that's essentially what we're doing through all our emissions. We're taking coal, oil, which is all plant material that was there from reversing that process, putting plants in and they're putting it back in the ground. Now, whether that's a thing that actually, whether we would even have enough seeds to plant the entire world of cover crop, I don't even know. It's a possible thing, but it's interesting to think about and just understand the importance of plant life to regulating global temperature and carbon dioxide. The cover crops are Sudan grass, buckwheat, and cowpeas.
For this season.
For the summer season, right. In the winter, our fields will be more winter rye, hairy vetch, Austrian winter peas.
Do you harvest anything from these cover crops?
No, we keep mowing it, and then eventually we'll just turn it under. But its primary purpose is just through its leaf and root matter to add that organic matter once it's worked in. And even more importantly, that I'm starting to realize, I didn't realize this for a long time, just keeping roots in the ground and keeping that biological activity going is so key to soil structure. So
Breaks it up.
yeah, and that when you don't have plants in the ground, it's, I mean, at least around here, the soils go to concrete like it. Welcome everybody, I'm Dan. I just want to talk real briefly about some goals that we have at Green Edge. One, and we'll talk about this in depth here in a minute, is trying to learn more and more how to treat the soil to increase its fertility and hopefully as it gets passed on, leave it in a better place than we found it, more or less. It's such a complex system. There's no way that we ever, as farmers and growers, can grasp the full nature of what soil is and understand everything about it and know exactly what to do at all times. It's a living organism like anything else, and it's extremely in flux. The more we can keep it as a focus to learn about it, continue to expand our understanding of it, then the better off we'll be. So that's a huge part of our mission here. Customer service is a big part of it, so learning each and every year how to better serve a farmer's market customer and a restaurant chef or a store manager or a subscription CSA customer. All those customers need things in a little different way or have different desires, and so the more we can be in touch with that and understand those customers' needs and wants, the better we can sell our products. So that's a big piece.
Dan, how many restaurants do you guys sell to?
There's probably about 10 here locally, and then another dozen or so. A third mission that's part of our goals is, how, and I feel like the word sustainability applies more in this respect than almost the soil end of it, is economics. How do we get a decent return for our work so that we can survive economically and stay afloat, become economically sustainable? And what we find is if we overemphasize any one of those areas at the expense of the other ones, then everything starts to not work very well. So, for instance, if we overemphasize our bottom line and we have to, make this amount of money no matter what the cost, and our quality standard lowers, then our customers aren't happy and we start to have less sales, etc. If we focus too much on the customer and make sure that every little leaf and every bunch is evenly on I call it the Michelangelo effect. We are artistes. We will get a perfect bunch all on, if we focus too much on that and then we don't get a reasonable return for our work, then that doesn't work either. If we spend so much time on a bunch that we get $2 for, it's not gonna work. So you're kind of finding those balances. How do you? And then same thing with the soil. If we push the soil too far and don't work to understand how to replace what we take, then in the end, that's not going to work well. For the whole thing to keep going. The whole process of the work becomes much more tangible, and we start to understand things on the plant and soil level much better if it relates to things that are already happening in our lives. From a scientific perspective, the soil, we have the physical aspect of it, the physical structure of it. So we have the sand, silt, clay, your air and your water, and your organic matter, your humus. That's what makes up, what you hold in your hand. And that's very similar to, in the human community, of just the general structure, physical structure of what we all live and move on. Our homes, our roads, our cities, our buildings, our pipes, our wires. That's what, to all the little people in the soil, that's what the structure is. Depending on the ratio of sand, silt, and clay, depending on your organic matter content, depending on how air and water flows, that's going to determine and significantly affect what kind of infrastructure those communities in the soil can build and what they can live in. You can essentially enhance or destroy micropopulations depending on how you treat the soil, more or less. There are many, many forms of carbon. It's kind of shocking to think about that the graphite in our pencils is pretty much straight carbon, and so is the diamond in our rings. But they're obviously incredibly different substances. Both of them are 100% carbon. And in the soil, or in our soil amendments, there's a lot of variation. Whether your carbon is coming in the form of compost, whether it's coming in the form of biochar, charcoal, whether it's coming in the form of humates, which is a strata in the soil that's similar to coal, but not really. It's a different substance, but it's very carbon. A cover crop that you till in that gets digested and broken down all the way into constituent parts and that kind of form. There's many, many different forms of carbon, but they're all going to do different things and create different homes. And so that's more what we're trying to do, is create a variety of homes that can create the greatest diversity of organisms. And that's what leads to the biology end of things, is how can we enhance the diversity of the microbe life in the soil. The more we do that, then they start doing the job of feeding nutrients to the plants, and they do, because they've been doing it for millions of years longer than we have, they just do it better. They do it better and way more efficiently. What we find ourselves on is a trajectory of needing to add less and less to the soil. And even within organics, we struggle with this, because I know for years here at Green Edge, we were on what I feel like was not a very good path. We used organic fertilizer. It was chicken manure based. Folks use this, and it's not bad. I'm not saying it's a bad thing to use. But what we found was, year after year, we were having to add more and more and more to get the same effect. And on top of that, our weeds were getting worse, our insects were getting worse, our disease problems were getting worse. And it was this, I'm like, what? This trajectory that we're on, we're having to buy more in, do more work to get the same, and it wasn't stopping, So I was like, there's got to be some different way of looking at this. And so that's sort of led us on to just tweaking, not shifting entirely, but tweaking a lot of what we do to try to find a different way that has the different trajectory, that has a trajectory of working with the natural processes is more, so that we have to add less, do less work, kind of get out of the way more, and let the organisms that have evolved an understanding that's far beyond us, at least as a community. I know they're not conscious like we are, but in the same sense, they're just better. They're way better at it.